Hello everyone, how are you? Today we're going to talk about section 2.10. What do I mean by it? Like for example, when something moves with a constant velocity. So let's take for example, what do I mean by a constant velocity? Let's go over here. Let's create this page template. It can be this. Okay. What do I mean by a constant velocity? Take a look with me. Let's say for example, I'm moving, for example, from a school until I get, for example, I reach home. Let's see if someone starts moving over here with a speed 2 meters per second. After I get midway to the street, also its velocity stays, for example, 2 meters per second. Go to the right. After some time, also the velocity stay what meter per second. As you can see, speed don't change. Speed doesn't change, it means we call constant velocity, of course. Speed and velocity, what the difference? Speed, it show me the value, velocity show me direction. So if he's moving to the right, from school to his house at 2 meters per second, to the right, it's velocity, so constant velocity. Okay, what I call this type of motion? This type of motion, I call it URM. Now what do I mean by URM alone? U means uniform. Uniform, it means don't change. Don't change. R from a word called rectilinear. Rectilinear. Rectilinear means, for example, just a straight line. M represent motion. يعني for example, gonna be moving. So that's what we mean by URM. Now what do we mean by another type called UARM? It's called uniform accelerated rectilinear motion. What do I mean by that? It means over here I'm moving by a constant acceleration. Okay, again, what do I mean by acceleration? It means two things. Either I'm speeding up or I'm slowing down. Acceleration in general. If we say slowing down, it means another name called deceleration. Okay. Let's go now to the second group. So for example, let's recall the rule for acceleration. Acceleration is change of velocity over what change in time. Let's take this example with us. Let's see, I'm moving from school until home. I'm gonna stop by several points. Let's say I drop some student over here, B, C, and so on. I have different position. Let's say, for example, when I was in school, the bus was not moving, so the velocity was 0 meters per second. At position A, after moving on the highway, it was velocity 2 meters per second. Let's take, for example, take him 1 second. For example, from A to B, he took also 1 second. His velocity was 4 meters per second. From B to C, 6 meters per second. And over here, for example, let's see, also I'm still moving. That's it. So what's going to be the acceleration? As you can see, acceleration, change of velocity over change on time. As you can see, from here to here, I'm increased my velocity by how much? 2. From here to here, got what? 2. From here to what? 2. So if I increase my speed by a constant factor, or for example, I can say, for example, 2 minus 0 over 1 equal to 2. Or another value gonna be 4 minus 2 over 1 also gonna be 2. So if I'm increasing my speed in a fixed value, and please we call this constant acceleration. Okay, we call this type of motion UARM. Okay, got it? That's about the idea. Now let's go about the equation of motion. Here we're going to do it. So let's get back to our book. This equation of motions, the one over here on the left side of the book, this and this is UARM. Pay attention. It's telling me that I can use this rule only if we have UARM. I can use this rule while doing, I got this rule only for URM. Now what do you mean by each one alone? We're going to see now. Let's go to our example over here. It's telling me at 11:35 a yacht cruising with a constant velocity 15 meters per second toward what the shore, spotted 4,000 meters from the latter. Determine the equation of motion. Here. Let's get back over here, guys. Now we have at each type, for example, it has equation of motion. The one we took is just simply x equal to vt plus x0. What do I mean by that? X represent position on number line, or sometimes I give it another name called distance. I'm gonna talk about it later. V represent velocity. It can be positive or it can be negative. T represent time. Should be in second. Here velocity should be in meter per second. X0, where I was initially. That's about URM. So now let's again read together what the question was. The first step to know any question in physics, or for example any problem solving physics, I have, for example, to draw it. I have to, for example, visualize it. So it's telling me at 11:35, let's complete. It's telling me at 11:35 a yacht cruising with a constant velocity 15 meters per second to the shore, spotted at a distance 4,500 meters from the latter. Okay, let's go over here to my Samsung notes. And let's get it. I have first example, I have to visualize what I have, a problem solving. So it's telling me at time 11:35 we have a yacht cruising at a constant velocity of 15 meters per second toward the shore, spotted 4,500 meters from the latter. So let's see, for example, I have over here the shore, and over here I have, for example, the latter. I put it from myself, I put it here. So I have a small yacht cruising toward it. This yacht away from here 4,500 meters and is moving with the velocity 15 meters per second. At what time this was? At 11:35 a.m. That's our first drawing. So what steps I should do? Step 1, draw a figure for yourself. Draw a figure visualizing for yourself, understand it for yourself. Second step, try to transform the picture into a number line. Third one, put all the given on it. Fourth one, you have to know it. Choose a reference point. When we talk about reference point, it's a point where x, I suppose, it equal to 0. Okay, and of course it choose a positive sense. So let's guys over here. Let's go to our picture. So I have a yacht moving to the right toward the shore. Its velocity was 15 meters per second. It was far away. This. So now I'm gonna draw for myself a number line. I'm gonna suppose, for example, that my shore has position x equal to 0, and my yacht over here, the yacht, is standing over here. Of course, we know that a number line, everything to the right of a 0 gonna be a positive number, everything to the left gonna be negative number. It's telling me in the example, this is far away 4,500 meters. So logically here the position gonna be minus 4,500 meters. And time equal to 11:35 a.m. Good. But I forgot one thing. I have to choose a positive sense. Positive sense is just a repeater. It shows in direction that give me all the vectors gonna be in this direction. Everything gonna move this direction gonna be positive. And we have a velocity. This guy moving over here with velocity 15 meters per second. That's gonna be my first step. Second, he told me get equation of motion. Equation of motion just is simply an equation represented, so I can use it later to substitute values in it and give me the unknown values. So take a look. Since it's telling me cruising at a constant velocity, velocity. Constant velocity, it means it's URM. I have only one equation for URM. It's x equal to vt plus x0. X represent position and velocity. You look at them. So what's gonna be over here? X equal to vt plus x0. Pay attention. Always time should be unknown. Time should be unknown because I might lose it later, depend on the given that give me. And x is gonna be also unknown because I'm gonna use it also later. So what do we have? Initially the yacht was at minus 4,500, so this is gonna represent x0 or where he was initially, and velocity gonna be. So over here x gonna be 15t minus 4,500 meter. This is gonna be equation of motion. I told you many times. Keep x unknown and keep time unknown. Now we're going to see y. Now let's get back to our question. Determine the equation of motion. That's we do it. Did you use the position at what time? Take a look. Position at what time? 11:36. We started moving 11:35. But position, pay attention. Position represent what? X. So let's get back to our equation of motion. So that's gonna be part A. Let's go to part B. It's telling me get x when time 11:36 a.m. Okay. So I want to get this value. Let's get back to our equation of motion. Let's write it. So x equal to 15t minus 400 meter. Pay attention, this should be in seconds, this should be what? In meter. Okay, I want to get this. How we get it? He gave you the time. Okay, so initially the time was 11:35. He wants the time after moving, after time 11:36. 11:35 to 11:36, how much time left? How much time it moved? It moved only 1 minute. And 1 minute gonna be what? 60 seconds. So now this value gonna be substituted over here to give me the position. So x equal to 15 multiplied by 60 minus 4,000. Use calculator. So here we're going to have negative 3,600 meter. This is the position at x equal what? 3,000. So if I wanna do it over here logically, the number should be over here at 11:36 a.m. because as he moves, this distance gonna decrease with respect to 0. Gonna decrease. Let's go to part C, for example. Part C, what is telling me? Find the time it takes to reach what? Shore. Remember, shore, I suppose it is x equal to 0. Good? I'm gonna take the time, how much it take for him to get the shore. He started from 11:35. I'm gonna see how much it take for get the shore. And then get what time should be reading this instant. Okay, so x final should equal what? 0. Let's get back to our equation of motion. X equal to 15t minus 4,500. So when x final was 0 over here, let's try to find t. 15t minus 4,500. So 15t is solve for t. Divide by 15. Divide by 15. So we're gonna have over here. Time, for example, gonna be with me. Time gonna be 300 seconds. Or, for example, gonna be 5 minutes. So the question is telling me he started at 11:35 a.m. and it takes for him 5 minutes to reach the shore. So at what time? What time was reached? So of course, if it was 11:35, move 5 minutes, gonna be 11:40 a.m. That's about the example. Now let's get back to question 2.1. Let's solve this, for example. We can solve the other one. It's telling me Arnold and Richard are 100 feet apart. Arnold can run speed at 8 meters per second, while Richard can move at what speed? Meter per second. If the two boys run at the same instant straight toward each other, when and where they gonna meet? When means time, where means position. Where means t, here represent x. So we're going to see. Let's go over here now. So first step, as I told you, let's see, for example, over here. exercise 2.11. So Arnold and Richard are 140 meters apart. Draw anything, represent whatever you want. Just a visualization for yourself. Let's call this Arnold. Let's call this Richard. It told me that all of them are 140 meters apart. Good. It's telling me that the Arnold can run with a speed, so velocity needs direction, but pay attention for it. It was 8 meters per second, and for Arnold, let's say letter case A means for Arnold. Velocity for Richard equal 6 meters per second. Okay, he's telling me if the two boys run at the same instant straight toward each other. Say toward, يعني for example, one should have to the right, other should what move to the left. When it means time, where it means x. So that's my first step. Let's get back over here. What I told you, draw a figure visualizing for yourself. Try to transform the picture into what? A number line, put all the given and choose positive sense. So this is gonna be, let's choose a number line. Let's get Arnold, and here for example be Richard. Let's choose Arnold as reference point. Reference point, يعني x over here gonna be 0. Position for it. If Arnold x equal to 0 and Richard 140 meters away from it, x for Richard gonna be 140. X for Richard gonna be 140. Here I have 8 meters per second goes to this side, and 6 meters per second goes to this side. All of this I chose it from myself. And now let's choose everything move to the right is positive. This works on what? Only on velocity, because velocity is a vector quantity. Okay, the trick over here, let's get equation of motion for each one alone. For example, Arnold. What's the equation of motion? X equal to Vt plus x0. Okay, here gonna be 8t plus 0. Why 8t plus 0? Because it's moving to the right, velocity gonna be positive. Plus 0 because he was an x equal to 0. Let's go to what? Richard. X equal what? This velocity is 6 meters per second, but it's moving to the left, opposite to one I suppose it. So it's gonna be minus 60 plus where he was positioned at 140. That's x for A, and here's x for R. Okay, when they're gonna meet each other, they're gonna hit each other, they're gonna have same x. So meet, it means having same x. Or for example, you can say, for example, transitive property. So how to solve it? X for A equal to x for R. So 8t equal to minus 6t plus 140. And now solve for time, because now there is no distance in this equation with me. There is no distance. I'm gonna solve for time. Take this other side, change sign. So 8t plus 6t equal to 140. So over here, what do I have? 8 plus 6 gonna give me 14t equal to 140. Divide by 14, divide by 14. So t gonna be 10 seconds. Okay, I got time, but he also asked me where. But guys, I can substitute the time in here or in here. It will give me same value. I'm gonna prove it. So x for A equal, for example, 80. X for Richard was minus 60 plus what? 140. Let's substitute the value. So 8 multiplied by 10 equal to 80 meters. X for R gonna be minus 6 by 8, by 10, plus 140, and minus 60 plus 140 also gonna give me 80 meters. So in any one you choose, it's gonna give you what? Also same answer. That's about section 2.10.